We begin our program of discovering the correspondence between geometric curves and equations with the simplest case, the straight line. The complexity of the geometric curve increases, so will the complexity of the analytic equation. The line is a vital concept of mathematics and enters into our daily experiences in numerous and interesting useful ways. The straight line is a locus of a point that could be expressed in the equation of first degree. In our study of the straight line, we shall first discover a correspondence between a line and a first degree equation in x and y. The equation will represent the line, and the line will be the graph of the equation. Mathematically, it is given by the equation ax plus by plus c is equal to 0. The equation of every straight line is expressible in terms of the first degree. Conversely, the graph of a first degree equation is a straight line. The following are the different forms of the equation of a line. Line parallel to a coordinate axis. Point-slope form. Equation of a line through 2 points. Slope-intercept form. Reduction from general equation of first degree to the slope-intercept form. Parallel and perpendicular lines. Intercept form. Suppose we start with a fixed line in the coordinate plane. The line may be parallel to the y-axis. First, let us consider a line L, parallel to the y-axis, and at a distance k from the axis. The abscissas of all points on the line are equal to k. So we see at once that an equation of the line is x is equal to k. Conversely, the equation x is equal to k is satisfied by the coordinates of every point on the line at a distance k from the y-axis. Hence, the line L is the graph of the equation. Next, let us consider a line parallel to the x-axis, still at a distance k from the axis. The ordinate of all points on the line are equal to k, so we see at once that an equation of the line is y is equal to k, where k is the directed distance of a line from the axis. Let us take this one as an example. We are to sketch the graph of the line x is equal to 2. In this problem, where x is equal to 2 is the equation of the line, we know that the abscissa of all points on the line are equal to 2. So the value of our x is equal to 2, thus giving us the graph of your line parallel to y-axis located at distance 2 from our y-axis. Our next equation of the line, y is equal to negative 3. This time, because of our equation which is in terms of y, our line is parallel to your x-axis, with all the points located at negative 3. This is now the graph of our line. The point-slope form. The equation of the line with slope m and passes through the coordinates x sub 1, y sub 1 is given by the equation y minus y sub 1 is equal to m times x minus x sub 1. The point-slope form fails when the line is parallel to the y-axis, since the value of your m or the slope for vertical lines is non-existent. Let us take this one as an example. Find the equation of the line through 3 and negative 6, perpendicular to the line joining the points 4, 1 and 2, 5. Sketch the line. Line through 2 points. To find for the equation of the line that passes through 2 points, x sub 1 y sub 1 and x sub 2 y sub 2. First, we have to solve for the slope using the equation slope m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Your slope is the rise over run. Next, we substitute the slope and any of the 2 points in the point-slope form. That is y minus y sub 1 is equal to m times x minus x sub 1. If the 2 points given have the same abscissa, the line is parallel to the y-axis with an equation x is equal to k. where k is the common abscissa of the 2 points. Let us take this one as an example. Find the equation of the line through the points 3, -5, and -6, -2. Sketch the graph. The slope-intercept form. The equation of the line of slope m and y-intercept b is given by y is equal to mx plus b. Let us take this one as an example. Find the equation of a line with slope 2 and intersecting the y-axis at point 0, 1. Sketch the graph. Reduction of the general equation to the slope-intercept form. We have here our general rule. To reduce the equation of any line not parallel to the y-axis to the slope-intercept form, solve the equation for y. When this has been done, the coefficient for x is the slope, and the constant term is the y-intercept. Let us take this one as an example. Reduce the equation 3x plus 4y minus 6 is equal to 0 to slope-intercept form and determine its slope and y-intercept. Parallel and perpendicular lines. Parallel lines are lines with the same slope. Given two lines with the following equation in slope-intercept form, y is equal to m sub 1 times x plus b sub 1. Y is equal to m sub 2 times x plus b sub 2. The two lines are said to be parallel if and only if your slope 1 is equal to your slope 2. If we are given the equation in general form, a sub 1x plus b sub 1y plus c sub 1 is equal to 0, and a sub 2x plus b sub 2y plus c sub 2 is equal to 0. The two lines are said to be parallel if and only if the value of your a1 is equal to the value of your a2, and the value of your b1 is equal to the value of your b2. Perpendicular lines are lines whose slopes are negative reciprocals. Given two lines with the following equation in slope-intercept form, y is equal to m sub 1x plus b sub 1, and y is equal to m sub 2x plus b sub 2. The two lines are said to be perpendicular if and only if m sub 1 is equal to the negative 1 over m sub 2. For the general form of the equation, it follows that the perpendicular lines are a sub 1x plus b sub 1y plus c sub 1 is equal to 0, and b sub 1x minus a sub 1y plus c sub 2 is equal to 0. Let us take this one as an example. Write the equation of the line through the point 3, negative 1, parallel to the line 3x plus 2y is equal to 6. Sketch its graph. Example number 2. What is the equation of the line that passes through the origin and perpendicular to the line through the points negative 1, negative 2, and 2, 3? x-intercept form. The equation of the line with x-intercept A and y-intercept B is x over A plus y over B is equal to 1. Let us take this one as an example. Determine the equation of the line with x-intercept of 2 and y-intercept of -2. Sketch the graph. The directed distance. Here, we will solve for the line to a point, and from a line to a line. For the directed distance from line to a point, given the line ax plus by plus c is equal to 0, and the point x sub 1, y sub 1, the distance from line to point is given by this equation. D is equal to the equation of the line a times x sub 1 plus b times y sub 1 plus c all over the square root of a squared plus b squared. The sign of the denominator must be taken the same sign as b, or if b is equal to 0, the same sign as a. The sign of the distance d may be positive or negative, according as the point may lie above or below the line. Example: what is the distance from the line 3x minus 2y is equal to 5 to the point 3, 4? Distance from line to line. Given two parallel lines a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0, the distance from one line to another is given by the equation d is equal to c sub 2 minus c sub 1 over plus minus the square root of a squared plus b squared. Example: find the distance between the lines 3x minus 4y plus 6 is equal to 0 and 6x minus 8y minus 8 is equal to 0.